Welcome back, Akira Bike Project fans. Well, we left off the last video with building this feet-forward motorcycle frame jig. Trying to build the engine reduction cage on my warped welding table encouraged me to build my Certiflat weld table. And that came out pretty good, so coupled with that and the upcoming frame extension I wanted to do, that inspired me to build this 8-foot-long recumbent motorcycle frame jig. With the base of the frame jig done, I could then move back to the frame extension and the engine reduction cage. For the frame extension, I started with the headrest. I drew up the layout of the new headrest base and cut the parts, clamping them on my new welding table for tack welding, and I then TIG welded them in place. I moved on to the actual back of the head part of the structure. This time though, I plotted the layout with a pin plotter attachment I made for my CNC router, and used that as the guide on my welding table. Just as before, I cut and laid out the pieces on the guide, and then TIG welded everything into place. I moved on then to the second layer of the base of the headrest, this one incorporating some of the parts of the old headrest, and then fit test these onto the frame to make sure they looked good. I moved back to the welding table and fit it all together, including the vertical back of the head part of the headrest. You can never really have enough clamps as a welder. This was tack welded in place as well, with the diagonals just sitting freely for the moment. And with that, the tack welded new extended headrest was looking pretty good. I did another quick fit test of the bottom half of the headrest base, the one that incorporated existing pieces of the frame, just to make sure everything still lined up properly. I decided I would go ahead and final weld the headrest as is, since I could use the welding table to ensure it remains aligned during the warping that welding causes, instead of relying on a tall post in the frame jig later. I spent a few days though just practicing with the TIG welder to improve my welds, and experimenting with blending until the welds and blends were looking tolerable. Well, I think that would be good enough to proceed with the headrest, but I'll definitely be practicing more before doing the thicker walled primary structural tubing of the lower frame. I put the first layer of the headrest base back on the welding table, clamped it down, and TIG welded each side of each joint. Some positions did require some tricky clamping. I did the same with the second layer of the headrest base. And then I went ahead and started blending the welds. I did another fit test on the frame for the lowest layer of the base. With all the individual sections welded and blended, I set them up to get welded together on the table. Again, with a lot of creative clamping to ensure the structure has minimal warping with final welding. And taking care to make sure those diagonal back pieces fit just perfectly. With everything clamped tight and lined up, I went ahead and started welding everything together. Still though, being careful and using a welding sequence I would hope would minimize distortion. And with that, it looks like the whole structure came out pretty good. I can't be too impressed with my work though until I actually put it on the bike frame and see how it fits. There ended up being a little bit of warping on the lower rung of the base, bending it inward, maybe about 1/8 of an inch or 3/16 of an inch. Using an inverted C-clamp, I opened that back up with a little bit of force and it dropped right into the frame perfectly. There's always going to be a little bit of residual warping and built-in stresses in any structure you weld, but this was well within what I think were acceptable limits. Even the bolts that I originally used to mount the old headrests popped right in without much effort. Overall, I'm really happy with the way that came out, and I'm happy with the way the frame modification is progressing. In episode 12, I went over how the motor powering this build actually came in a few different sizes. The stock CX500 I'm using here puts out about 45 horsepower, but they also made a CX650 and a CX500 turbo and a 650 turbo that all fit the same mounting points, with that CX650 turbo hitting about 100 horsepower. When I originally planned this project out, I planned on starting with the smallest motor, the CX500, to make it less likely that I'd kill myself, and just swapping it out for larger, more powerful versions of the same motor as the build phases and testing progressed. I didn't realize, though, how rare those CX500 and 650 turbos were, so I was getting worried I'd have to plan on a different powertrain and testing plan. But amazingly, shortly after that video was published, someone just one town over from me put both a 500 turbo and a 650 turbo, both in running conditions, up for sale. Only 5,000 of the CX500 turbos were even made, and only 1,200 of the 650 turbos made it into the US. Yet here someone was selling both, for a good price too. So say hello to my new friends. I'll talk more about these bikes in an upcoming video, but I wanted to share this news since it was such an incredible stroke of luck. I also picked up this empty CX500 case for fit testing and mocking up the engine mounts and exhaust system, so I wouldn't have to keep lugging my newly rebuilt and painted motor in and out of the frame, probably scratching and dinging it up in the process. Getting back to the build, the engine will be mounted to the frame through vibration isolation mounts. My original mounts were just half-inch holes drilled into a steel bar with a rubber insert hosting a 3/8-inch bolt. It's a poor design for a vibration mount, and I'd only built the bottom 4 anyway, so I thought it was time to make these properly. And I had had a bit of practice already with these on the engine test stand. The new design would generally consist of a center bolt that screws into the engine, inserted into a steel sleeve. The sleeve has washers in front and behind it which compress onto the sleeve. Around the sleeve and in between the washers is the rubbery flexible material that would actually absorb the vibrations. The point of this is that when you tighten the bolt, it tightens against the washers which then compress the sleeve, and only compress the flexible material to the length of the sleeve and no more. This leaves enough flexibility for the material to do its job of absorbing vibrations. The whole thing then sits inside a tube mount that is connected to the frame with some kind of post, typically. I started off by removing the existing engine frame mounts. I then moved on to cutting the outer sleeves which hold the rubber inserts for each one, cutting them off on the lathe, and then chamfering the ends. Cutting out 10 in total. I cut the posts from 1-inch square tubing on the bandsaw, and marked the center line on the end of each post. Next, marking the intersection of the scribed lines with a center punch. Then drilling each post at the center punched mark with a hole saw on my drill press. Finally, all 10 posts and outer sleeves are cut. Of course, some of the posts are different lengths. I moved to the inner sleeves next, first facing the end, and then opening the inner sleeve bore up. These are 3/8-inch ID tubes, but the mounting bolts are M10s, so I'm opening these up to 10 millimeters. Finally, cutting each of the inner sleeves to length with the cutoff tool. They would also get a rubber washer, which was left out of the earlier graphic in the video, sandwiched in between the metal washer and the outer sleeve. The inner sleeve's length is equal to the rubber insert's length plus the 2 rubber washers. So even when tightened down, the rubber inserts and washers are not squeezed. So I can adjust the stiffness of the rubber by changing the type of the rubber or shortening the length of the inner sleeves, which squeezes the rubber more and makes it stiffer. Fit testing these and they look pretty good. The CX500 is a stressed member in the original bike and is not rubber mounted, so this is not necessary and may be overkill. But with the engine so close to the rider's back, I think mitigating vibrations will be a good idea. And I like the smoother ride instead of bone-rattling chaos. I can also replace the rubber inserts with aluminum and eliminate the vibration isolation completely if necessary or desired. With all the posts and mounts fabricated, I could start fitting everything onto the frame and engine. Okay, I got most of the vibration isolation mounts on here. You can see attached to the head on the left side, here's these 2. On the right side, those 2. Down below, these I'm waiting to get a longer bolt in, but they require a spacer so they don't clang against the engine while the engine's vibrating. And on the other side is the same thing. That one only needed about a 3/4 of an inch spacer. This one was 1 inch. I don't like having the spacers that long, but this engine has so many mounting points, I'm not too concerned about that. Going around now to the back of the engine, these two were pretty easy to mount. There's actually a receptacle cast into the engine that fits these M10 nuts perfectly. So those ones were really, really easy. This bottom bar is a little more difficult. So I ended up finding this 3/8 inch threaded rod. It's I think 12 inches long. And then I have this 1/2 inch OD, roughly 1/2 inch OD bar with 3/8 inch ID. And this will slide in there perfectly and give me a nice spacer to fill in the gap. You can see if the 3/8 inch rod is in here, there's way too much play in there. So with this, it works out pretty good. I just cut it to the exact width of the engine. It's a little bit of a tight fit on the 3/8, but it gets in there pretty good. I'll go around to the other side. And there you go. Nice vibration engine mounts all the way around, perfectly fit. I think that should provide some excellent support for the engine while simultaneously making for a nice smooth ride. Well, that is it for this video. Thanks for watching. I want to welcome my new patrons, Jordan H. and Hugh R. Thank you both sincerely for your new support. I want to thank all my patrons. And if you like this project and want to help expedite it, please become a patron for as little as $1 a month. The patron support really helps me purchase supplies and tools, and critically, to outsource complex components and get them fabricated in days instead of weeks or months. Thank you for watching. See you soon.